All right, so in this introductory video about engineering, I just want to give you some of the big picture stuff about what we're trying to accomplish here. And one of the first things I want students to get out of this is that we're all engineers, right? So we all build things to solve problems, and that's the ultimate definition of what an engineer is. So a beaver is an example of an engineer because they have a particular problem, they need a home, and they need to be close to their food source, things like that. And so they create these structures. But so are our kids who put rocks in a stream. I used to love building forts in the house and putting rocks in a stream to dam it up. Just thought it was fun. So I think there's an innate desire to do stuff, to build stuff, and then to try to solve some sort of problem. So from the Next Generation Science Standards, NGSS, I kind of messed with the definition a little bit that they have, which is basically engineering is the process of solving problems, right? And that's the key thing, that scientists try to answer questions, engineers try to solve problems. But they try to solve problems by making something, right? Either an object, a tool, or a process or a system. So it doesn't have to be a physical object, but we often think about engineers as being people that create things, but it can also be a process or a system. But the other thing that's really important for engineering is that solutions must work within some set of constraints. So there's always some constraint for an engineer. Often money is a big one, right? And there's some sort of cost component to it, size, functionality. It could be anything, material usage, all kinds of stuff that can be a constraint. All right. So what is the engineering design process? So all engineers go through a particular cycle, and there is no technical start or end to this process, but it will often start with the ask phase, where there is some sort of identification of a need, and then figuring out what the constraints are around that need, and then you go into the problem-solving process. But typically that's where it is. However, there are times when you're down at the testing side of things, and as you're doing a test, you realize it failed, whatever you were trying to do, but you realize, hey, this might actually solve a different problem that we have, and then you can go through that process starting a test. But typically it's going to start at ask, and that's certainly where we are going to start all of our processes. So start at ask, go to the research where you kind of look into it and think about what might happen. You might actually go read some articles or look at some websites, things like that. Imagine possible solutions. So as you're doing that research, oftentimes ideas come up. So this is the brainstorming side of things. And it's like, well, we could do this or maybe that and this. And then you create a plan that you think is going to work based on that research and that brainstorming. And then you create it, like some sort of prototype, test it, see if it works or not. Does it fail? Does it not fail? And then try to improve that design. And that's probably one of the most important parts about understanding the engineering design process. It is not a one and done thing. Their engineers I can't imagine a time when they would have a question and they would try one thing and they're like, oh, yep, this is good enough, done. That might happen every once in a while, but most of the time it's an iterative process where they're continually going back over and over and over again and trying to make it a little bit better, try to make it fit within the constraints a little better, something like that. So ongoing process. Key takeaways or key goals for this project, making students feel like engineers, using that term with them, make sure they keep hearing, oh, wow, you all are being such great engineers today. Really love to see this engineering process. To get in their head that this is something they could be. Working through that design process and kind of having it maybe up on the board somewhere physically, or you post it somewhere so that you can keep going back. Like, we're in the plan process right now. We are in the test phase of this process. Kind of making sure they understand that they are following a sequence. Even though much of it is intuitive, they're following a sequence of events that help them to be engineers. Reflection, it's a big one. How did it go when you tested this? Did that work or not? And then how do we revise it? And engineers are actually notorious for loving to take things to failure, right? So you build something and you're like, okay, it fit the constraints that we had. It had to hold this much weight or whatever, but What happens if we could take it a little further? And they look for the failure point. The failure point is actually encouraged because it tells you something about your design. First of all, it's going to tell you, how good it is relative to the constraints, but also where are the potential points of improvement later on. So failure is not a bad thing in engineering. It's actually, you want to get to failure point because you want to find out what works and what doesn't. Working through emotions, like we all need to work on this, adults and everyone, but there'll be frustrations, right? There'll be times when you're going through a process and it doesn't work. Helping them to remember to breathe and to not work while they're angry or frustrated, because that often leads to breakage, or it leads to something. I've had students throw things before, right? So it's like just making sure that they are managing, or they're monitoring their emotions, paying attention to them, and taking a break when they need to take a break. Super important to do that with the project. And then have fun. Obviously, one of the biggest goals is we want to have as much fun as possible. So that's the engineering design process. And I just wanted to remind you all again that we are all engineers, whether we think of ourselves as engineers or not, we are. And that's the message that I would love for you to keep conveying to the students as you go through the project. All right, have fun.